Alright, welcome back to the channel. So we've got one more video on the discriminant, and what we've got here is a slightly bigger problem where we can use again the discriminant to go and solve it. So let's have a quick look at how we can do this. Now, given that the x-axis is a tangent to the curve with equation this, find two possible values of k. So first thing I'm going to try to do is sketch out what this problem is trying to get us to do. Now, here's the axes, and what we're told is the x-axis is a tangent to this curve here. Now we know that this curve is a U-shape, quadratic, because it's a positive x squared. And so I guess we could also say that the y-intercept is 4 because that's on the end there as 4. So maybe I'll put that in as 4. And so what we've kind of got to figure out, I guess, is what this value of k needs to be so that when we draw this curve in, it kind of just touches the x-axis because it says the x-axis is a tangent. So maybe it could look something like this where it touches the x-axis there, or it might be like that where it touches the x-axis here. And so maybe that's why it says find two possible values, because it could look like either one of these sketches that I've drawn. So what we do know is that if it touches just one point over here, that this equation should have one solution. So don't be fooled here. Just because it says find two possible values of k, it doesn't mean that there's all of a sudden two real roots. That's not what it's saying. This here is touching the x-axis at just one point. And so what we've got to remember is that there is one solution. So we can start by saying b squared minus 4ac needs to equal 0. Now, for our equation over here, a is going to equal 1 because there's a 1 in front of there. B, remember, is the coefficients of the x terms. So we've got k in front of there, but we've also got a minus 3. So for B, we'll have k minus 3. And for C, that's just a constant on the end, which is just 4. So let's start filling this in. So we'll have k minus 3 all squared. Take away 4, lots of 1, times by 4, and that's all got to equal 0. Let's expand out this double bracket. So we'll have k squared minus 6k plus 9. Take away 16 is equal to 0. And then if we just simplify this down, we'll have k squared minus 6k, and then 9 minus 16, that's going to give us minus 7 is equal to 0. There we go. And now hopefully we can get our two values by factorizing this here. So maybe k, and then we'll go with minus 7 plus 1 equals 0. And then from here, that means k must equal to 7, and k must equal to minus 1. So there we go. It seems like these are two values of k, and when those two values, or each one independently, is put into there, we'd get an equation that only touches the x-axis at one point. So maybe you can go and try that for yourself. Why don't we just substitute that in? So we'll have y equals x squared, and maybe let's try 7 first. So plus 7 x minus 3x plus 4. And then if we simplify that down, that will be x squared plus 4x plus 4. Now if we were to go and solve this quadratic over here, that would be x, and then I think that's just plus 2 and plus 2 in fact. So that means x equals minus 2, x equals minus 2 when we set that equal to 0. And so what we know then is that this here must be minus 2, and obviously you can see you've got one solution there. Do the same thing, try doing that with minus 1, put that in place of k, go and solve it just like I've done, and hopefully you'll just get one value and it should be positive. Okay, so bigger problem there with discriminants. Hopefully you've understood that, and I think we move on to modelling next.